Okay, so have you ever like been playing a video game and you're just like blown away by how the characters seem to know exactly where they're going?
Hmm?
Like they're dodging walls, weaving through crowds. It's like they've got some kind of internal GPS or something.
Yeah. Yeah, it's really easy to just kind of accept it when you're playing right. But there's
Yeah.
actually a ton of tech working behind the scenes to make all that happen.
And that tech, that's what we're going to be diving into today. We're going to be taking a look at something called a navigation mesh.
NavMesh for short.
Exactly, NavMesh for short. So get ready to level up your game dev knowledge because this deep dive is all about how those virtual characters find their way around.
It's actually a really cool concept. Imagine like you're dropped into a video game level, you got all this stuff around you,
Mm.
buildings, trees, maybe even like a couch or two. If it's somebody's apartment, it could be messy.
Yeah, you know.
But the point is, there's all this stuff dictating where you can and can't walk right. Now imagine someone created this invisible map highlighting all those walkable surfaces. That's essentially what a nav mesh is.
So it's like a blueprint, but for movement.
Exactly. And the game AI uses this blueprint, this nav mesh, to navigate the world. And the process of creating this nav mesh, developers call it baking.
Baking. Okay, now you're speaking my language, although knowing the show, we're probably not talking chocolate chip cookies.
Sadly, no. It's kind of technical. But basically, the game engine analyzes the entire 3D world and figures out every single surface a character could walk on. It looks at everything. Slopes, stairs, even the size of the characters themselves.
To make sure they don't get stuck.
Precisely.
Okay, that's super cool. But is the nav mesh always an exact copy of what we see in the game world?
Not necessarily. Sometimes you have to make trade-offs for efficiency.
Oh, right, because games have to run smoothly too.
Exactly. So, like, take stairs, for example. In the actual game, you see individual steps. But in the nav mesh, those might get simplified into a single slope.
So it's about finding a balance between being accurate and keeping things running smoothly. Makes sense. But how do the characters actually use this nav mesh? Is there like a little digital tour guide leading them around or something?
That's where the NavMesh agent comes in.
NavMesh Agent, okay. Are we talking like little AI robots running around inside the game now?
Haha, not quite. Think of it like this. It's a special component that developers attach to a character. It's what allows them to understand and interact with the NavMesh. Without it, well, you just have chaos.
Yeah, I can imagine characters just running into walls, getting stuck on each other.
Exactly.
Although now I kind of want to see that. It'd be hilarious.
It would be pretty funny. But yeah, it would definitely get old fast.
Okay, so these NavMesh agents, they're using the NavMesh to get around avoiding obstacles. Are we basically talking about self-driving cars at this point?
It's a pretty good analogy.
Mm.
And just like with cars, NavMesh agents have their own set of rules. They have a radius and a height that determine where they can fit.
So a giant monster isn't going to be squeezing through a doorway meant for like a tiny little creature.
Exactly. It's not just about following the path. It's about knowing if you can actually handle it.
That makes sense. But what happens when something gets in the way unexpectedly? Like, let's say a big crate falls out of nowhere. Does the AI just run straight into it?
That's where things get really interesting. We have something called NavMesh Obstacles.
Obstacle. Okay, so it's like the name suggests anything that gets in the way.
Exactly. That crate you mentioned. It's not just a visual change. It actually affects the NavMesh itself.
So the nav mesh gets redrawn on the fly.
You got it.
Whoa. Okay,
Yeah.
that's some seriously smart tech.
And developers can fine-tune exactly how those obstacles are handled. There's this cool setting called Carve.
Carve. What's that do?
It basically determines whether an obstacle carves a permanent hole in the nav mesh or just a temporary one.
So like a giant boulder falling, that would be a permanent detour, but something smaller, maybe it's only temporary. That's so smart.
Exactly. It all depends on what makes sense for the gameplay.
But even with this perfectly laid out roadmap, not all paths are created equal right. Like, what about those situations where some terrain is just tougher to get through? Like, if we think about the real world, think about walking on a paved road versus like a muddy swamp. Do we just expect our AI buddies to trudge through the mud every time?
You're thinking about the right way. You've just hit on this concept of nav mesh areas and costs. It's all about adding weight, you know,
Yay.
like giving certain areas a higher cost to make them less appealing for the AI to walk through.
So using our earlier example, the AI would be less likely to go for that muddy swamp if there's a nice clean sidewalk right there.
Precisely. Higher cost, less appealing path. It's almost like if you're choosing between taking the highway or like a scenic route, Sometimes you don't mind taking the longer path if it means a smoother ride.
Totally. Okay, so we've got this virtual roadmap. We've got these AI agents making decisions, obstacles, popping up costs, influencing their choices. It's like a whole symphony of game dev magic going on behind the
It
scenes.
really is.
But how does this actually translate to what we see on the screen? Like when I click on the screen, how does my character actually know to go to that spot?
Ah, you've just stumbled upon one of the most common applications of nav meshes. It's called raycasting.
Raycasting.
Right.
Okay, now that sounds complicated.
It's actually simpler than it sounds. Imagine like an invisible line shooting out from your mouse, click into the game world.
Yeah.
And that line, it's checking for intersections with the nav mesh, basically telling the game, hey, this is where the player wants to go.
So when I click on a spot, the game's drawing a line to figure out the best path using the NavMesh.
Exactly.
That's wild. Okay, so that's for player-controlled characters. But what about those non-player characters? You know, the ones just kind of wandering around, living their best lives?
Yeah.
How do developers make their movements look so natural? They're not just randomly walking around, are they?
Not exactly. It all comes down to the nav mesh and something we mentioned before, NavMesh agents.
Right.
Developers can actually place specific points on the nav mesh, almost like checkpoints. And they use pathfinding logic to guide the AI between those points.
So it's like saying, hey, the shopkeeper needs to walk between the counter and the back room, make it look natural.
Exactly. And the nav mesh and the agents, they handle the rest.
Wow. For something I never even knew existed until we started this deep dive, NavMesh is pretty darn impressive. But I have to imagine it's not always easy for developers, is it? What kind of challenges do they bump into when they're designing these systems?
There are definitely challenges, especially as games get bigger and more complex. Think about those huge open world games.
Oh, yeah.
Just imagine trying to bake a nav mesh for a world that massive.
And it's probably constantly changing, too.
Exactly. There are time constraints, processing power limitations. It's a constant balancing act. And even the smallest mistake can throw the whole thing off.
It's like that saying, one bad apple can spoil the bunch. Except in this case, it's one misplaced line of code, and the whole AI system goes haywire.
Pretty much. And on top of that, it's not enough to just have AI that can move around. They have to feel alive, too.
Oh, right, because nobody wants to play with a bunch of robots that all act the same.
Exactly. Players crave unpredictability, a little bit of chaos. That's what makes games exciting. So developers are always looking for ways to make AI smarter and more responsive.
Okay, so how do they do that? Spill the secrets.
Well, a big part of it is combining nav meshes with other AI techniques.
Like what?
Things like behavior trees, state machines, even some light machine learning can come into play.
Okay, hold on, you're losing me. Behavior trees, state machines. Are we building Skynet now?
No, we're not quite there yet. It's not as complicated as it sounds. Think of behavior trees like flowcharts for AI decision making.
Okay, I can kind of picture that.
So instead of just blindly following the path, they have these guidelines that help them choose the best action based on the situation.
Gotcha. So it's like giving them options instead of just one strict path to follow.
And then you've got state machines, which basically determine how a character transitions between different behaviors.
Okay, so give me an example.
Like, is the character patrolling? Are they chasing the player? Are they running away in terror? The state machine handles all those transitions.
Oh, that makes sense. So it's not like they're stuck in one mode, they can adapt on the fly.
Exactly. And then there's the whole world of machine learning, where AI can actually learn and evolve based on the data it's given.
Wait, are you telling me these AI characters can actually learn from my playstyle?
You got it. They analyze your moves, your strategies, and adjust their behavior accordingly. Imagine fighting an enemy that actually gets smarter the more you fight them.
Okay, now that's both really cool and kind of terrifying.
Right. It's one of the most exciting and rapidly evolving areas of game development right now.
So we've got these behavior trees, state machines, even machine learning being used to make AI more dynamic. But let's bring it back to nav meshes for a sec. How do developers actually make all of this happen? Is there like a secret coding language just for nav meshes?
Not a secret language exactly, but it does require some serious coding know-how.
Yeah, I bet.
Luckily for us, though, most game engines like Unity, which we talked about earlier, they have built-in tools for working with nav meshes.
Oh, that makes sense.
So it's not like developers are starting from scratch every single time.
So it's like prefabricated building blocks then?
Exactly. They're called APIs,
Oh.
and they're a lifesaver for game developers.
Okay, so they're not writing every single line of code, but they still need to know how to use these tools effectively.
Oh, absolutely. It's a specialized skill set for sure.
I bet. Okay, so we've covered a lot of ground here. We talked about how NavMesh's work, the challenges involved, even got a glimpse into the future of game AI. But before we wrap things up, I want to swing back to something we mentioned earlier, those off-mesh links. The jumps,
Mhm.
the leaps, all those cool moves that make games more dynamic.
Yeah, those are always fun to work with.
But I imagine those off-mesh links, they must present some interesting challenges for pathfinding. It's not like the AI can just magically teleport across those gaps.
You're exactly right. It's like suddenly introducing this giant chasm in our nice, neat roadmap. Remember we were talking about the NavMesh being like a network of roads?
Yeah.
Well, off-mesh link is like having to jump your car across that chasm.
Okay, that's a terrifying but accurate analogy.
Right. So developers have to find creative ways to bridge that gap and make those transitions look smooth.
So it's not as simple as just telling the AI, hey, jump over there. There's actually a whole system in place to make those actions look and feel realistic.
Exactly. A lot of times they have to create custom animations, custom code. They have to factor in things like the distance of the jump, the height, the timing of everything, even how the character should land when they reach the other side,
It's like they're choreographing a stunt, but for AI.
pretty much. And then you have to think about those situations where you've got multiple characters all trying to use the same off-mesh link at the same time.
Oh man, can you imagine? It'd be like a digital traffic jam.
It would be chaotic for sure.
Mm.
And that's something else developers have to consider. They need to implement queuing systems, prioritization, maybe even some clever camera tricks to avoid those awkward pileups.
Wow. It's amazing how much detail goes into every little aspect of game development. It really makes you appreciate those games even more.
For sure. It's a testament to the skill and the dedication of game developers.
Absolutely. This deep dive has been a wild ride. We've gone from invisible roadmaps to AI agents, dynamic obstacles to cost analysis, even touched on the crazy world of machine learning. And I don't know about you, but I feel like I've leveled up my knowledge big time.
Me too.
All
It's
right.
been a blast.
And to think this is just one tiny piece of the massive universe that is video game development. It really makes you wonder what other secrets are hiding behind those digital curtains.
Right. There's always something new to discover.
And that's what we're here for, to dive deep and cover those secrets and share them with all of you. So until next time, keep exploring, keep playing, and keep those questions coming.
See you next time.